So why is this important? Why do we care that it's normally distributed? Well, if the sampling distribution is normally distributed, we can use that Z table that we used in the last video. We can use a Z table because a Z table gives us probabilities for a normal distribution. And so before we are using it on individual values from the population, but we can also use it for the sampling distribution if we know it's normally distributed. So that's why it's important to us that we know that it's normally distributed. And we just need to know the population mean and the standard deviation, because then we can find the mean of the sampling distribution and the standard error, which is the standard deviation of the sampling distribution. And if we know that, then we can find z-scores, and if we can find z-scores, we can find the probabilities. We can do some probability questions what the sample means, because we have a z-score and we know that the sampling distribution is normally distributed. So we're going to have a slightly different z formula. So our old one that we're using from the individual values from a population would be z equals x minus the population mean divided by the standard deviation. Now we're going to use it slightly different when we're going to find probabilities for a sample mean. So we're going to have z equals x bar, which is a sample mean. So we're replacing that x with the sample mean because we're trying to find the probability for the sample mean instead of just an individual value of x. So we're going to just replace that. And then now we're going to put the mean of the sample means instead of just the population mean. And then divide that by the standard error, which is the standard deviation of the sample mean. So it's just, just replacing things, and it's pretty intuitive how we're going to replace it. So now we have this new z formula. So you can have two separate ones just depending on which probabilities we're going to try to find. And so if we're going to find probabilities based on an individual value, you're going to use this one on the left, and if you're going to find probabilities for a sample mean, you're going to use the one on the right. So let's do an example of finding a z-score for a sample mean. So say we have a normal distribution of test scores across America, and it has a mean of 80 and a variance of 9. So this is what we used in a previous example. What is a z-score for a sample mean of 80.75 based on a random sample of 16 Americans? So first you want to see if the central limit theorem holds true, and we kind of already went over that, right? There's a normal distribution. So, and we also have a random sample, so we can use the central limit theorem. So the sampling distribution is going to be normally distributed because we have a normal distribution and a random sample. And then the mean of the sample mean is going to be 80, and the standard error is going to be 3/4. Now we're going to find the z. So the z equals the sample mean minus the mean of the sample means divided by the standard error. So our sample mean was the 80.75 because this was based on our random sample of 16. So that's why this is the sample mean, and that goes first. And then we're going to subtract the mean of the means, which was, we figured out was 80, and divide it by our standard error of 3.4. And so we're going to get 0.75, and 3 divided by 4 is 0.75, so we're going to get a z-score of 1. So that means this sample mean is 1 standard error above the population mean. Okay, so let's do another example. So say we have a skewed distribution of test scores across Asia, and it has a mean of 100 and a standard deviation of 12. What is the z-score for a mean of 96 based on a random sample of 36 Asians. So again, we know that sampling distribution is normally distributed because we have 36 Asians in our sample, so it's at least 30. And we know that this central limit theorem holds true because it's a random sample and we have it in at least 30. And then we have a mean of the sample means of 100, and then we found that our standard error would be 2. So we're going to use a Z formula. So we're going to fill in first our sample mean of 96, and this 96 was based on our 36 Asians in our sample. And then we're going to subtract off the mean of our sample means, which is 100, divided by standard error of 2. So 96 minus 100 is -4, divided by 2 equals -2. So this means that our sample mean of 96 is 2 standard deviations below the mean of all the samples, which is equal to the population mean. Okay?